Hi. What we have here, we have a graph of a function, and you can see this function as a cubic. That's not the most important thing. We're just going to call this function of x. Now what we want to do is we want to actually have a look at what happens if we graphed the function of the derivative. So we're looking at what the gradient does, what the slope of this line does as it moves along. So we know that our derivative gives us the gradient of the tangent. There's certain key points. Now that at our stationary points, our tangent is horizontal, so our derivative is going to be 0. So our derivative of our function at those 2 points is going to equal 0. So if I graphed those, at that point I would have a 0 value, and at this point I would have a 0 value. Let's have a look at what happens before my 0 values. Can you see at this point I have a derivative that's increasing, or I have a slope that's positive, and it's slowly becoming less positive until it becomes 0. So what I have is my derivative function is going to be in the positive realm. Okay? It's not going to be negative. Now I also have it between my maximum and minimum point. What's happening to my graph? It's decreasing. So remember, my derivative gives me my gradient at any point in time. So my gradient through all this time is going to actually be negative. So my derivative is going to be down here to the negative value. At this point it comes back up to 0. Okay, so it's a little bit negative, it becomes more and more negative, becomes slightly less negative until it reaches a gradient of 0. Even though my function here is negative, what's happening to my gradient? My gradient is increasing, so my gradient is going to be in my positive realm. So if we look at this point through here, can you see that there? That's roughly where I have the steepest slope, or the steepest negative gradient. So if I graphed this, what I'm going to end up with is I'm going to end up with something that looks a bit like this. Okay, a bit like a quadratic. Now, I apologise for my dodgy drawing, but you can see that from here up to here, my gradient is positive. So my gradient graph is a positive value. Between my maximum and minimum points, my graph is decreasing. So my gradient is in the negative realm. And at this point, it's the most negative. It's decreasing at the fastest rate. Remember, the derivative gives us our rate of change. Here, my gradient is 0. And then after here, even though my function is negative, it's actually increasing. So my derivative graph is positive because my gradient is going up, my gradient is positive. I know it takes a little bit to get your head around, but it's an important concept to understand, so it's worth a try.